Well, John.
Hi, Sean. we're here.
Yeah, it's a great way to end up here at the IMEC booth for a couple of reasons. One is that they're focusing on the 450 millimeter.
Oh, the 450, yes. Yep. The Flemish government has come in supporting it with dollars. They're going to be one of the first fab in Europe with 450 nanometers. It's very cool.
Yeah, and also how they're applying different techniques and technology. Techniques to other industries like healthcare and, as you mentioned, the smart grid and
social media.
That's right.
Bringing the best of semiconductor processes and business smarts and knowledge to a whole bunch of things.
And the one person that we should bring in that knows all about that is
you mean?
Yes, I mean the executive vice president right here at IMEC, Ludo Deferm, right here. Thank you for joining us.
Nice to meet you, John. Nice to meet you, Sean.
Join us.
Thanks.
So this is the tall convention. Ladies and gentlemen, everyone over here is over 6'5", I guess.
I think so.
Yeah.
It's a club.
Yeah. So talk a little bit about the focus here at SEMICON West about your 450 millimeter technology.
Okay. You know, 450 is an important step towards, I would say, a new industrial challenge. I think from Europe it was not clear when we would engage into it. So as you also have heard about the announcement that Intel is going to invest into ASML. ASML is a European company. We have collaboration with both Intel and ASML.
Perfect. Good.
So, and we have a roadmap for 450. So also our government will support our roadmap. That means we're going to set up a clean room, a 450 clean room, starting building in 2014, ending end of 2015. But already we can add some equipment towards our 300 millimeter clean room, which has a 450 extension. So we can start. So we already have a collaboration with KLA Tenker on surf scan kind of technologies for inspecting 450 millimeter wafers. So we're starting. And it's good that now things become more clear. And there is a roadmap which is defined now, and everyone hopefully supports it.
Well, you're going to get a head start on the competition then, huh?
Depends, of course, what you call competition. So we are a research center, so our focus is really to do process development, compare different process options so that the industry can take whatever they need for 450.
Good. John and I were talking earlier about how you're applying different techniques to other industries, and we found that a little fascinating, especially in the energy and medical, healthcare.
It's true. I think that nanotechnology, nanoelectronics, and especially, of course, have become so small that they have the same size or smaller size than viruses and bacteria. So interfacing with cells, with viruses and bacteria become, I would say, it's not easy, but it becomes feasible. So I think we can mean something more to healthcare. We can bring technology which we have brought to ICT, which has accelerated ICTs very fast to very dense circuits, good systems, lower costs. We can do the same thing, I think, within the healthcare environment. But also in the food environment, for instance, where you want more food inspection, a lot of sensory together with telecommunication kind of tools can be used there to make things more efficient. And I think in the future, electronics will be in everything.
Yes.
But it will be cheap and it will be invisible. Now it's still visible, your iPads, your iPhones.
Yeah.
In healthcare and food, it will become invisible. And that's the goal.
And using the semiconductor knowledge and business models and whatnot, is that, I mean, it can't be a smooth transition, but it's got maybe, as applied to healthcare, that's got to be some new challenges.
I think that's a good question what you're asking there. Yes, models. I mean, the business model in semiconductor were not straightforward either 20 years ago.
Oh, okay.
Everyone was vertical. So it was very difficult to share things.
Yes.
It was very difficult to say, okay, there's generic technology. No, everything was proprietary.
Yes.
I would say if you go to the medical direction, you have the same problems. Of course, you have a lot of strong, big companies who wants to own everything. So they have to learn which part they can share without jeopardizing their position in the market. So that's a learning phase we have to go through. But it has to move faster than the semiconductor industry has done before.
Fascinating.
Excellent. Well, thank you very much for your time.
Okay,
I really appreciate it. And John, thank you. We'll see you next time.